So in this particular video, I will be solving check your progress 22.3. So the first question is, if sine theta is equal to 20 by 29, find the values of cos theta and tan theta. So to solve this question, first we will draw a right angle triangle and we can name this as A, B and C. So if I consider this angle to be theta, so AB will be equal to 20, AC will be equal to 29. Why? Because sine is nothing but opposite side divided by the hypotenuse. So opposite side is given as 20, hypotenuse is given as 29. So now right now we need to find what is the value of BC. To find the side length BC, we will be making use of Pythagoras theorem. So we have AC square is equals to AB square plus BC square. So what is AC equal to? 29. So 29 square is equals to AB is equals to 20. So 20 square plus BC is the side length that we are supposed to find. So we have to write it as it is. So BC square is equal to 29 square, which is equals to 841 minus 20 square, which is equal to 400, which is equals to 441. So BC is equal to square root of 441. So to find the square root of 441, we will be making use of prime factorization. So 3 divides 441. So 3 1s are 3, 3 4s are 12, 3 7s are 21. Again 147 is further divisible by 3. So 3 4s are 12, 3 9s are 27. Now 49 is not divisible by 3. So we have to consider the next prime number that divides 49. It is 7. So 7 7s are 49. So 7 1s are 7. So prime factorization of 441 is equal to 3 square into 7 square. We know that square root means whole to the power 1 by 2. So 441 whole to the power 1 by 2 is equals to 3 square into 1 by 2 into 7 square into 1 by 2, which is equals to 2 into 1 by 2 is nothing but 1. So 3 to the power 1 into 7 to the power 2 into 1 by 2 means it's again equals to 1. 3 sevens are 21. So square root of 441 is equals to 21. So BC is equals to 21. So what will be cos theta? It is nothing but adjacent side BC whole divided by the hypotenuse AC. So BC is equals to 21, AC is equals to 29. Then tan theta, which is equals to opposite side AB whole divided by the hypotenuse AC. So AB is equals to 20, AC is equals to 29. So in the second question, it is given that if tan theta is equal to 24 by 7, you are supposed to find the values of sin theta and cos theta. So again, to solve this question, we will draw a right angle triangle and we will name this as A, B and C. Now again, if I consider this angle to be theta, so AB will be equal to 24, BC is equals to 7, because tan is nothing but opposite side, that is AB, divided by the adjacent side, which is BC. So it will be 24 and 7. So again we need to find the value of the side length AC. To do that, we will be making use of Pythagoras theorem. So AC square is equals to AB square plus BC square. So what is AB is equal to 24 square. BC is nothing but 7 square. So 24 square is equals to 576 plus 7 square is equal to 49. So if you add 576 plus 49, the answer that you will get is 625. So AC square is equals to 625. So this implies AC is equals to square root of 625. Again, to find the square root of 625, we have to make use of prime factorization. So 5 divides 625. 5 ones are 5, 5 twos are 10, 5 fives are 25. Again, this number is also divisible by 5. So 5 twos are 10, 5 fives are 25. So 5 fives are 25, 5 ones are 5. So we got to know that 625 is equals to 5 to the power 4. Again, square root of 625 means 625 whole to the power 1 by 2, which is equals to 5 to the power 4 whole to the power 1 by 2, which is equals to 5 square, which is equals to 25. So square root of 625 is equals to 25. So we got to know that AC is nothing but 25. So after finding AC, we can directly find what is sine theta, which is equals to opposite side AB divided by the hypotenuse AC. So AB is equals to 24, AC is equals to 25. Then cos theta, which is equals to adjacent side BC divided by the hypotenuse AC. So BC is equals to 7, AC is equals to 25. So in the third question, it is given that cos A is equal to 7 by 25. So we are supposed to find the values of sin A and tan A. So again we'll draw a right angle triangle, but this time we will consider this vertex to be A, so that we can easily find what is sin A and tan A. So if we consider this side, this vertex as A, then this vertex will be B and this one C. So cos is nothing but adjacent side divided by hypotenuse. So cos A is equal to 7 by 25 means BA is nothing but 7, AC is nothing but 25. So again, by making use of Pythagoras theorem, we have to find the side length BC. So we have AC square is equals to BC square plus AB square. AC is nothing but 25. So 25 square is equal to BC. We don't know the value yet. So we write it as it is, plus AB is equal to 7. So 7 square. So this implies BC square is equals to 25 square, which is equal to 625, minus 7 square, which is equal to 49. So 625 minus 49 is equals to 576. So BC is equal to square root of 576. So once again, to find out the square root of 576, we have to once again make use of prime factorization. Okay. So since 576 is even, it is divisible by, so 2 to the 4, 2 8s are 16, 2 8s are 16. So once again by 2, so 2 1s are 2 4s are 2 4s are. So 2 7s are 2 2s are. So 2 3s are 2 6, 2 1s, 2 8s, then 2 9s, then 3 3s, 3 1s. So 576 is equals to, so how many 2s are there? 1 2 3 4 5 6. So 2 to the power 6 into, there are 2 3's, so 3 square. We know that square root is nothing but whole to the power 1 by 2. So square root of 576, that is 576 whole to the power 1 by 2, will be equal to 2 to the power 6 into 1 by 2 into 3 square into 1 by 2. So this is equal to 2 cube into 3, which is equals to 8 into 3, which is equals to 24. So square root of 576 is equals to 24. So BC is equals to 24. Now again we need to find what is the value of sine A and tan A. So sine A is equal to opposite side BC divided by the hypotenuse AC. So BC is equal to 24, AC is equals to 25. Then tan A, which is equals to opposite side BC divided by the adjacent side AB. So BC equal to 24, AB equal to 7. So in the fourth question, it is given that cos theta is equal to m by n, and you are asked to find out the values of cot theta and cosecant theta. So once again, we will draw a right angle triangle and we will consider this angle to be theta. So this will be A, B and C. So since cos is nothing but adjacent side divided by the hypotenuse, so AB will be equal to m, AC is equal to n. So in order to find out the side length BC, once again we will be making use of Pythagoras theorem. So AC square is equals to BC square plus AB square. So what is AC equal to? AC is equal to n. So n square is equal to BC square plus AB is equal to m. So m square. So BC square is equal to n square minus m square. So BC will be equal to square root of n square minus m square. So BC is nothing but square root of n square minus m square. So cot theta is equals to adjacent side AB divided by the opposite side BC. So AB is equal to m, BC is equal to square root of n square minus m square. Then cosecant theta is equal to the hypotenuse AC divided by the opposite side BC. AC is equals to n, BC is equal to square root of n square minus m square. So in the fifth question, it is given that cos theta is equal to 4 by 5 and we have to evaluate cos theta into cot theta whole divided by 1 minus secant square theta. So to solve this question, once again we will draw a right angled triangle. So ABC, and we will consider this angle to be theta. We know that cos is nothing but adjacent side divided by the hypotenuse. So this side length will be 4 and this side length will be 5. Again, to find out what is AB, once again we will be using Pythagoras theorem. So AC square equal to AB square plus BC square. AC is nothing but 5. So 5 square is equal to AB. We have to find this value plus BC is nothing but 4 square. So your AB square is equals to 5 square 25 minus 4 square 16. 25 minus 16 is equals to 9. So AB is equals to square root of 9, which is equals to 3. Because if you do the prime factorization of 9, it will be 3 3s are 9, 3 1s are 3. So 9 is equals to 3 square. Square root means whole to the power 1 by 2. So 3 square into 1 by 2, which is equals to 3 to the power 1, which is equals to 3. So we have found out what is the value of AB. It is equals to 3. So first we will find the values of cot theta and secant theta. Then we will substitute those values in this given expression. So cot theta is nothing but adjacent side BC divided by the opposite side AB. So BC is equals to 4, AB is equals to 3. Secant theta is equals to the hypotenuse AC divided by the adjacent side BC. So this is equals to 5 divided by 4. So cos theta into cot theta whole divided by 1 minus secant square theta is equals to cos theta is given in the question 4 by 5. Cot theta we have just found it out 4 by 3 whole divided by 1 minus secant theta is nothing but 5 by 4. So 5 by 4 whole square. So 4 into 4 16 divided by 5 into 3 15 whole divided by 1 minus 5 square 25 4 square 16. So we get 16 divided by 15 whole divided by 16 minus 25, that is minus 9 whole divided by 16, which is equals to 16 by 15. So you have to take the reciprocal of this fraction and multiply that with the fraction that is there in the numerator, that is 16 by 15. So into minus 16 by 9. So this is equals to 16 into 16 means 256. 15 into 9 is equal to 135. So sixth question, it is given that cosecant theta is equal to 2 by root 3. You are supposed to find the value of sine square theta into cos theta plus tan square theta. Again, to find this value, we will draw a right angle triangle first, and we will consider this angle to be theta. And we will name this as A, B and C. Since cosecant is nothing but hypotenuse divided by the opposite side, so AC will be equal to 2 and AB is nothing but root 3. Again, to find the side length BC, once again we will be making use of Pythagoras theorem. So hypotenuse square, that is AC square, equal to sum of squares of other two sides, that is AB square plus BC square. So AC is nothing but 2, so 2 square is nothing but 4. AB is nothing but root 3. Root 3 whole square is equal to 3. We have to find out the value of BC. So BC square equal to 4 minus 3, which is 1. This implies BC is equal to square root of 1, which is equals to 1. So sine theta will be equal to opposite side AB divided by the hypotenuse AC. AB is equal to square root of 3. AC is nothing but 2. Then cos theta equals to adjacent side BC divided by the hypotenuse AC. So BC is nothing but 1. AC is equal to 2. So tan theta opposite side AB divided by the adjacent side BC. So AB is equal to square root of 3 divided by BC is 1. So the answer is square root of 3. So sine square theta into cos theta plus tan square theta is equals to sine theta is nothing but square root of 3 divided by 2. So square root of 3 by 2. Since we need to find sine square, it will be whole square. Cos theta is nothing but 1 by 2. So into 1 by 2. Tan theta is nothing but root 3. So it will be root 3 whole square. So root 3 square is nothing but 3. 2 square is equal to 4 into 1 by 2. Root 3 square once again equal to 3. So it will be 3 divided by 4 into 2, 8 plus 3. So it will be, if you take the LCM, it will be 3 plus 24 divided by 8. So 8 ones are 8 threes are 24. So 24 plus 3, 27 divided by 8. So seventh question, if cot b equal to 5 by 4, then show that cosecant square b is equal to 1 plus cot square b. So to solve this question, once again we will draw a right angle triangle ABC. So I have named this vertex as B because it will be easy to calculate what is the value of cosecant B, because directly I can say it is AB by AC. So once again it is given that cot B is equal to 5 by 4. We know that cot is nothing but adjacent side divided by the opposite side. So BC will be equal to 5, AC will be equal to 4. So in order to find out the value AB, once again we have to make use of Pythagoras theorem. So AB square is equals to AC square plus BC square. AC is equal to 4, so 4 square is nothing but 16. BC is equal to 5, so 5 square is equal to 25. So AB square is equal to 16 plus 25, which is equals to 41. This implies AB is equal to square root of 41. So AB is nothing but square root of 41. So cot B is already given in the question 5 by 4. So what will be cosecant B? This will be equal to hypotenuse AB divided by the opposite side AC. Hypotenuse is square root of 41 divided by AC is nothing but 4. So here we need to show that LHS is equal to RHS. So if we start with LHS, we have cosecant square B in the LHS, which is equal to cosecant B is square root of 41 by 4, the whole square, which is equals to square root of 41 whole square is nothing but 41. 4 square is nothing but 16. So in the right hand side, we have 1 plus cot square B. 1 plus cot B is nothing but 5 by 4, which is given in the question. So it will be 5 by 4 the whole square, which is equals to 1 plus 25 divided by 16. So if you take the LCM, the answer will be 16 plus 25, which is 41 divided by 16. Because since the denominator is 1, you can't directly add these two fractions. That's why you have to make the denominator of the first term also equal to 16. So then you find the LCM of 1 and 16, which is equal to 16. Then you multiply and divide the first term by 16. So it will be 16 by 16. Then you can add the numerator. So 16 plus 25 is equal to 41. So the denominator 16 as it is. So since your LHS is equal to RHS, we have proved that cosecant square b is equal to 1 plus cot square b if cot b is equal to 5 by 4. So in the eighth question, it is given that triangle ABC is a right triangle with angles equal to 90 degree. So there is a right angle triangle with angle C equal to 90 degree. So we are supposed to find the values of sine B and tan B. Since we need to find the value of sine B and tan B, I will be considering this particular vertex to be B and this vertex to be A. So tan is nothing but opposite side divided by the adjacent side. So AC will be equal to 3 and BC will be equal to 2. Again, to find out the value of AB, once again we have to make use of Pythagoras theorem. So AB square is equal to AC square plus BC square. So AB square equal to AC is equal to 3. So 3 square is nothing but 9. BC, which is equal to 2. So 2 square equal to 4. 9 plus 4 is equal to 13. So AB is equal to square root of 13. So what will be sine B equal to? Sine B will be equal to the opposite side AC divided by the hypotenuse AB. So AC is nothing but 3. AB is equal to square root of 13. So tan B equals to opposite side AC divided by the adjacent side BC. AC is equal to 3, BC is equal to 2. So in order to solve the ninth question, once again we have to draw a right angle triangle A, B and C. So it is given that tan is equal to 1 by root 3. We know that tan is nothing but opposite side divided by the adjacent side. So AC will be 1, BC will be root 3. From the second trigonometric ratio, it is known that tan B is equal to square root of 3, which you can write as square root of 3 by 1. So opposite side is square root of 3, which is already written as square root of 3. And adjacent side is 1, so which is once again written as 1. So we need to find what is the hypotenuse AB. So to do that, we will make use of Pythagoras theorem. So AB square is equal to BC square plus AC square. BC is equal to square root of 3, that is square root of 3 square is equal to 3 plus AC is equal to 1, so 1 square is equal to 1, so 3 plus 1 is equals to 4. So AB is equal to square root of 4, which is equals to 2. So AB is equals to 2. So cos A is equals to adjacent side AC divided by the hypotenuse AB. So AC is nothing but 1, AB is equals to 2. Then cos B, which is equals to adjacent side BC divided by the hypotenuse AB. So BC is equal to square root of 3, AB is equals to 2. Then sin A, which is equals to opposite side BC divided by the hypotenuse AB. So BC is equals to square root of 3, AB is equals to 2. Then sin B, which is equals to the opposite side AC divided by the hypotenuse AB. AC is equals to 1, AB is equals to 2. So here we need to prove that cos A into cos B minus sin A into sin B is equals to 0. Since you are supposed to prove that this expression is equal to 0, in the beginning you are not supposed to write equal to 0. So if you keep on writing equal to 0 each time you simplify a step, then you will lose marks because you are supposed to prove that this is equal to 0. So just write this expression, then immediately after writing this, put a equal to sign, then write what is cos A. Cos A is nothing but 1 by 2. What is your cos B? Cos B is nothing but root 3 by 2. Sin A, which is equal to square root of 3 by 2, and sin B is nothing but 1 by 2. So 1 into root 3 is nothing but root 3. 2 into 2 is equals to 4. So once again, square root of 3 into 1 is nothing but square root of 3. 2 into 2 is equals to 4. So square root of 3 by 4 minus square root of 3 by 4 equal to 0. So we have proved that cos A into cos B minus sin A into sin B is equal to 0 when tan A is equal to 1 by root 3 and tan B is equal to square root of 3. Given that if cot A is equal to 12 by 5, show that tan square A minus sin square A is equal to sin to the power 4A into secant square A. So first we will draw a right angle triangle and we will name this as A, B and C. We know that cot is nothing but the adjacent side divided by the opposite side. So AB is equals to 12, BC is equals to 5. So AC square is equals to BC square plus AB square. BC is nothing but 5, so 5 square is equal to 25 plus AB is nothing but 12, so 12 square is equal to 144. 144 plus 25 is equal to 169. AC is equal to square root of 169. In order to find out the square root of 169, we will be making use of prime factorization. So 169 is divisible by 13. So 13 ones are 13, 13 threes are 39. So 13 ones are 13. So 169 is equal to 13 square. So square root means whole to the power 1 by 2. So 13 square into 1 by 2, which is equals to 13. So square root of 169 is equals to 13. So we write that 13 here. So now we need to prove that LHS is equal to RHS. That is, left hand side of the equation is equal to right hand side of the equation. So in the LHS, we have tan square A minus sin square A. So what is tan A? From the figure, tan A is nothing but BC by AB, which is equals to 5 by 12. Sin A is equals to opposite side BC divided by the hypotenuse AC. So 5 by 13. So what is secant A equal to? Secant A is equal to the hypotenuse AC divided by the adjacent side AB. So 13 by 12. So tan A is nothing but 5 by 12. So it will be 5 by 12 the whole square. Sin A is nothing but 5 by 13. So it will be 5 by 13 the whole square. 5 square equal to 25. Then 12 square equal to 144 minus 5 square is nothing but 25. 13 square is nothing but 169, which is equals to, if you take the LCM, it will be 25 into 169 minus 25 into 144 whole divided by 169 into 144. So in the numerator, the answer that you will get is 625 divided by 169 into 144, which is equal to 24336. So if you get the same fraction on the RHS, then LHS will be equal to RHS. So then you will prove that tan square A minus sin square A equal to sin to the power 4A into secant square A. So in the RHS, we have sin to the power 4 into A into secant square A. Sin A is nothing but 5 by 13. So 5 by 13 whole to the power 4 means 5 into 5 into 5 into 5 divided by 13 into 13 into 13 into 13 into secant A is nothing but 13 by 12. So secant square A is equal to 13 into 13 whole divided by 12 into 12, which is equal to, you can cancel out two 13s. 5 multiplied by 4 times is equal to 625. Then 13 into 13, it is 169. 12 into 12, 144, which is equals to 24336. So LHS is equal to RHS. So we have proved that tan square A minus sin square A is equal to sin to the power 4A into secant square A. So in the last question, we are supposed to find out the value of sin A plus cos A. So sin A is equals to, from the figure, sin is equals to the opposite side BC divided by the hypotenuse AC. So BC is equals to A, AC is equals to B. So cos A is equals to the adjacent side AB divided by the hypotenuse AC. So it is C by B. So sin A plus cos A is equals to A by B plus C by B, which is equals to A plus C whole divided by B. So A plus C whole divided by B. So option second is the right one.